Okay, so now what we're going to talk about today is what happens when you're not given an equation, but you are given either a description of a graph or a graph, okay, um, of a parabola. So to start this, even though I know some of you really don't like graphing, the graph is actually your best friend. Okay, so a couple of ways these problems can be presented. One, they give you a graph of the whole thing. Okay, the second way is they will tell you where certain aspects of the parabola are. Now, they always have to tell you too. Okay, so they could tell you where the vertex is and where the focus is. They could tell you where the focus is and where the directrix is. They could tell you where the focus is and where the directrix is. Um, things like that. They can tell you the width and then the vertice. Okay, but they have to tell you two things. Okay, so let's go with situation one. I'm just going to draw you a picture of a parabola, and we're going to get the equation. Okay, so there's my xy axis. Oops. Oops. And there we go. Okay, so this right here is the directrix. This right here is the focus. This is the vertex. And here is my lovely parabola. Okay, so the first thing I usually do is I just kind of look at the graph and say, okay, so what kind is it? Is it a left or a right? Is it up or down? So this one is a right. Okay, so since it's right, okay, I know that my equation is going to look something like this. Now remember, you can use different forms of the equation. Okay, now since it opens right, you know that this guy is a positive value. Okay, all right, so you basically need four things. You need a vertex, and then you need a p-value. Okay, so vertex is pretty easy to find. You just go, let's see, there's 0, 0, right, 3, up 1. So we're actually going to do, oops, that should be a y. Okay, so 3, 1. Okay, so now we need to remember what p is. Okay, so p is the distance between the vertex and the focus. Or if you'd rather, the vertex and the directrix, whatever is easiest to count. So right here, I find that that distance is 2. So what I'm going to do is I'm going to put a 2 right there. Okay, so my final equation is going to be. Now remember that you can rearrange these. So alternate forms of your answer. Oops. Okay, could be this. Okay, it could be, I'm just going to go for the 2 most common. Could be this. Okay, so you just need to be aware that that's what those look like. Okay, so my favorite type of problem is when they tell you where certain things are. Okay, so we're going to start out with, I'm going to tell you where the focus is. And then I'm going to tell you where the vertex is. Okay, so you don't really have to have a like very like detailed picture, but you do probably would want something that would let you know what the heck is going on. Okay, so I'm going to draw a small xy axis. All right, so my focus is at negative 5, 3. I'm going to put that little f by there. And my vertex is located at negative 5, negative 6. Okay, so that's negative 5, negative 6, and that's negative 5, 3. Okay, since I know that the parabola has to go through the vertex and has to kind of surround my focus, my parabola is going to go up. Okay, so I know that the parabola opens up. Okay, because the vertex has to be part of the parabola has to go around the focus. Okay, all right. So now I know that my formula, whoops, looks like this. All right, so I have a vertex. They told me that. Now I know that 1 over 4p is positive because it opens up. Okay, so, and now remember that p is the distance from the vertex to the focus. So we're just going to count. So that's 3, and then that's 6. So that's 9. Okay, so p is equal to 9. So now it becomes a matter of filling in what you figured out. So let's see. Vertex, remember down goes with the y. So negative 6 and negative 5 and 9. Okay, so let's kind of make it look pretty. And again, you can rewrite this so it's one of in the alternate forms. But there's my answer. Okay. All right. So the next one that we're going to do is probably the one that folks find the most complicated is when I don't give you the vertex. I'll give you the focus and I'll give you the directrix. Let's put a, whoops, a line there. Okay. So let's say the directrix is at x equals, let's say, -2. And the focus is at -6, 4. Okay? So again, I'm going to draw an xy axis and use what I know about parabolas to help me out. Okay. So the directrix is x equals -2. Oops. So that would be right here. Okay. The focus is at -6, +4. So let's see, 2, -2, -4. Just let's count -6, 4. Okay, there's your focus. Let's just double check. 1, 2, 3, 4, 5, 6. Okay, so I know that my parabola has to go away from the directrix and around the focus. Okay, so according to this diagram, my parabola opens left. So 1 over 4p, when I'm all done, will be negative. Okay, now I also know that the vertex must be in the exact middle. Okay, so I need to find the middle between the directrix and the focus. So my vertex is right there. So my vertex, using my graph, is at -4, +4. Cool. Now, remember that P is the value between the vertex and the focus. Okay, so P is 2. So if you want to graph the parabola, look like this. Okay, but that's kind of enough to know what I need. Okay, so it opens left. And now it's just a matter of -4, 4, and then 2. So my final equation, let's make it look pretty. All right, hopefully that was helpful. If you need to see more examples, please send me a text and we'll do more examples. I'll make a video or attend a Zoom meeting. Okay, have a great day.